All right, so let's get into this next lesson, which is dealing with the angle measurements inside of triangles as well as outside of triangles. Now, the measurement of interior and exterior angles is an Indiana standard. So this doesn't actually have a number to it, but I am calling it lesson 8.7. So our goal is to be able to find the sum of interior angles, but then they also take you to the next step of the Indiana standard, which is how do we find the exterior angles? So we'll talk about what that means here in just a moment, but this really is an easy lesson if we will learn one key fact. And that one key fact is no matter what type of triangle I have. So in this example, they're showing us an equilateral triangle on step 2. But I can have an acute, an obtuse, a right, an equilateral, and an isosceles, or a scalene triangle. It doesn't matter what kind of triangle I have, all three angles inside of it. And when we talk about an angle, we're talking about where two edges come together at a point or at a vertex. When I measure those and I put them all together, they have to equal 180 degrees, no more and no less. When I add them all together, if I don't get 180 degrees, then I've done something wrong. I either did something wrong in my math or I did something wrong in my measurement. The other thing that we need to know, which should have been taught either last year or the year before, but something that's important to understand, especially when we get into the second half, which is exterior angles, is that a straight line is always equal to 180 degrees. So if I have those two pieces of information, I should be able to see a direct correlation between them. If a straight line, also known as a straight angle, is 180 degrees, that means if I am facing forward in a location, I jump up and I spin and face in the opposite direction, we call that a 180-degree jump because I'm going in the absolute opposite direction. That's why a straight line is 180 degrees because I'm going in both directions without any kind of angles. If a straight line is 180 degrees, and I cut this triangle's corners all apart and then I stack them together, I will see that they can come together and make a straight line. So that's why the three angles of a triangle will always equal 180 degrees, because no matter what size the triangle is or what type of triangle it is, I can put them all together and make a straight line. So keep in mind, straight lines 180 degrees, interior angles of triangles 180 degrees. So when I'm given the triangle, I know that all three angles added together have to equal 180 degrees. So if I have the equation, or in this case, they say symbol, but if I have the equation, no matter what the numbers are that represent those angles, I can add x, y, and z together. They have to equal 180 degrees. Or if I'm given the model, if I'm given the triangle itself, no matter what those three angles added together, they have to equal 180 degrees. So I've given you two spaces for examples down there at the bottom of your paper, and I'd like you to fill these out as I walk through them so that you know exactly how we're going to use these. So let's say that y is equal to 90 degrees, and then let's say that x is equal to 30. So label those on your example 1. If I know what two of those angles are, then I can figure out what the third one is by doing the math. If I know that 90 plus 30 is 120, and they have to equal 180 degrees, then all I have to do is subtract those, and I have the 180 degrees minus 20, so I know z has to be 60 degrees. And then I could check them by adding those all together. 90 plus 30 is 120, plus 160, that does equal my 180 degrees. So on your example 2, what I want you to do is label it with some different numbers, and then I want you to do the math to figure it out. So on your second example down there on the right, I want you to label that y is 87 and x is 36. Pause the video to do the math and then check your answer and make sure that you got the right one before we move on into the next step. So hopefully your first step was to add 87 and 36, because you know that when I add all three together, they have to equal 180 degrees. So if you added 87 and 36, you should have gotten 123 degrees. Then you should have subtracted those from 180. And then you would have found that z is equal to 57. And then if you do a quick check, you can even do it on your handy dandy calculator. You can add all three of those together, 87 plus 36 plus 57, and you'll see that does equal 180 degrees. So when we're given triangles, or in this case, a word problem that has a triangle, then I just need to know what I'm looking for. Now, once again, a lot of times you're going to be given a whole bunch of extra information. We're being told that we're making a flag, we're being told what it's made out of, but none of that matters. The yellow, the blue, the white, the black, none of that matters. And the left-hand orange triangle doesn't matter. What matters is that we're being asked to find the value of x. X is that top right-hand corner. Finding the value of x, well then, if I look at my previous example up or on the previous page, then what I see is I need two angles in order to add those and subtract that from 180, but I only have one. Or do I have more than one? Look closely at that triangle. It's a right triangle because in the bottom right-hand corner, I have that right angle indicated. And we should know by now that a right angle is 90 degrees. So I am actually given two measurements, and now I can do my math. If I add my 90 and my 55 and my x, that's my expression. I know that it has to be equal to 180 degrees. That's my equation. And when I have an equation set up, now we're back to algebra in lesson 5. So we've been doing algebra now for 11 weeks. It's hard to believe, but 5, 6, 7, and now 8, we've been doing algebra, and all of you know how to do those steps. First, I have to do any math that I can on the left-hand side where the variable is. So I'm going to add my 90 and my 55. That gives me that x plus 145 equals 180. And what are the two steps that we always do in algebra to solve for a variable? The opposite function on the opposite side. So when I look at my variable, I look at what math is happening to it. I'm adding 145 degrees. So I'm just going to do the opposite of adding 145, and that is subtracting 145. That just cancels those out. That gives me my variable alone, which is what we've said for 11 weeks now. That's my goal. So then I go to the opposite side. And once again, the opposite side just means I'm going to go to the other side of the equal sign where the variable is not located. And I'm going to do the exact same math that I did where the variable is. So I do the opposite function on the variable side, cancel it out. Then I go to the other side of the equal sign and do the exact same math. And that opposite function was subtracting 145 degrees. And when I subtract those, I have to borrow. So my 8 gets crossed out and there's a 7 and I carry a 10. Now, when I'm grading your assignments, this is one of those steps where you're not showing it. Some of you, most of you are. Some of you aren't showing it and you're messing up your subtraction. So if you indicate on your paper, and yes, I know that takes an extra half a second, and for some of you that seems like a lot, but if you show that you're borrowing from the 8 and it becomes a 7, and therefore you're carrying a 1 over and that becomes a 10, then your subtraction should be okay. Because if you're not borrowing, then what I'm usually seeing is you're saying to yourself, I can hold up 0 fingers and take 5 from it. And you're going to end up with the answer of 45. And that's not correct. So I have to borrow because I can't take 5 from 0. And I end up with a 7 where the 8 is, end up with a 10 where the 0 is, and now I can take 5 from 10. And 10 minus 5 is 5, and 7 minus 4 is 3. So the answer that we should get is that our missing angle, the x in that triangle, is equal to 35 degrees. Now, we said last week we're talking about checking our work. And once again, most sixth graders seem to think that checking work means to look and make sure you have an answer and possibly your label and hopefully your work on a question. But that's not what I mean by checking your work, right? What I mean by checking your work is I either rework it or I do a reverse math question to prove that my answer is correct. And in this case, if I'm going to check my work and I'm being told what two angles are and I found the third one, if I just do the math, then I should be able to get 180 degrees. So if we're saying that x is equal to 35 and I add 35, 55, and 90, I should get 180. Well, 35 plus 55 is 90, and 90 plus 90, It is 180. I've checked my work. I know I'm right. So my answer is X is equal to 35 degrees. So once again, you get points for showing your work. You get a point for the correct answer, which is 35. And on this one, you have two labels. You have X and the degree sign. This type of problem is worth 4 points. Moving on. Before we jump into solving for example 2, we've got some things we need to go over because we have things that look kind of like hieroglyphics and we may not know exactly what they're showing us. So I tried to introduce this to you on our last slides and lesson when it dealt with the area of composite shapes. This is what we call shorthand in geometry, and you use shorthand on a regular basis. You probably just don't realize it, right? In math, if you're writing the label inches, instead of writing the word inches, you might put an IN. Or for the label pounds, instead of writing the word pounds, you might put an LB. Now, I'm sure there's an interesting factoid out there as to why we use an LB for pounds. I don't know what that is, but we do. When we write things in writing, and you have like Wednesday, you might abbreviate it or do shorthand for WED instead of writing out Wednesday, or October OCT, right? So we do shorthand on a regular basis. We just don't think about it. It's just abbreviating. And so I was showing you that in geometry, we can use shorthand. And shorthand or abbreviations in geometry, is usually going to give us some type of symbol to indicate the shape, as well as some specific information. Sometimes it's one letter, and sometimes, like in this case, since it's a triangle, they're giving us 3 letters. And those 3 letters, in this case, since it's a triangle, are indicating that those are the vertices or the points of the triangle. When I look at it then, and this is a note that I would like you to add to your line so you can understand what it's showing you. When I see that triangle followed by a capital ABC, then I say it as triangle with vertices of ABC, or I could just say triangle ABC. So if you would just write that down, you can put quotations around it so you know that I'm just showing you how we would say this. I don't have to look at it and be confused as what that is and then get stumped and stop. So reading it, it says the measures of the angles of triangle with vertices ABC are in the ratio 1:4:5. Well, ratio, that's a term that we haven't had for a while. So let's review what that means. All the way back in the first month of school, we did ratios in Unit 1. And we learned that ratios is just simply comparing two things in a very specific order with their numbers. And one of the early examples we had in our book was that there were 2 girls for every 3 boys, and we had to write those out in ratio form. So if the ratio was girls to boys, then we wrote it in the 3 different ways in which we show a ratio. They're all said 2 to 3 in this example, but we have 3 ways we can show it. First is with the word 2. The other one is with a colon, like we're seeing here in this example 2 in this math problem. Or we also said we can show a ratio as a fraction, but all 3 are said as 2 to 3. But this ratio is showing us 3, right? And we had a quick introduction early on, and I don't think we've seen it very often since. So I'm going to show you what that's meaning. We're comparing 3 things now, but this sentence says there were 2 girls for every 3 boys compared to the total number of students. I'm not given another number. So that's where we had to calculate the third number, right? So if I have in the order, according to this statement, girls to boys to the total, or I could have put an S for students, then I still have the 2 to 3, but I had to find what the total was, and that was adding 3 and 2, which gave me 5. So it's just putting them in the order in which we're told in the math problem. So when I apply it to this information, for example 2, it asks what are the measures of these angles. Well, then I have to understand what math I'm being asked to do just from the information before I get into the math. So they're saying that in the sentence, once again, for the triangle with vertices of ABC are in the ratio of 1, 4, and 5. So if I know that it's in the order of 1, 4, and 5, and in the triangle we're being told that it's in the order of A, B, and C, then those are corresponding to one another, right? So if I have triangle A, B, and C, then I'm going to put those together. And then they tell me Well, then we're going to represent the measurement for angle A as x. Don't know exactly what that measurement is yet, but I'm going to go a step further, right? So I can see that in my ratio that for the B, it's 4. Well, specifically, it's going to be 4 times x. And then for angle C, I can see that it's 5. Well, that is going to be the 5 times x because x is always going to be equal to 1. So what I end up with by putting these two together in the correct order, that I have x, which is the measurement of angle A, to 4x, which is a coefficient touching a variable, right? We know that's multiplication, but that's going to be angle B, to 5x, which is going to be 5 times x, which is the measurement for angle C. So I have to take all of that information and create an expression and change it into an equation. Well, the expression, hopefully by now we understand that if I add all three angles together, so I'm going to take my x and I'm going to add my 4x and I'm going to add my 5x, and my equation where I add the answer, I know that has to equal 180 degrees. So I just simply plug that information into my math problem. So I have x plus the 4x plus 5x, and that's equal to 180 degrees. Now, we review how we do algebra. All the way back in Unit 5, when we started doing algebra, we then talked about having like terms. And like terms means that if they have the same variable, then I can put them together by adding the coefficients. And if they're a constant, a whole number, I can add those together. Well, I have all of these with a label of x, but also in our review of combining like terms, we talked about, well, that x doesn't have a number in front of it, but it does have that understood coefficient of 1. Any variable by itself does have a coefficient of 1, because when we ask ourselves, well, how many x's are there in that first term? There's 1, right? So it is going to be 1x. So if I can combine like terms, I have 1x plus 4x plus 5x. Well, 5 plus 4 is 9 plus 1, that's 10. So on the left-hand side where my variable is, I know that I have 10x, and that has to be equal to 180. Well, welcome back to algebra. We're going to do the opposite function, and then we're going to do it on the opposite side so that I can get my variable alone. And once again, a coefficient touching a variable is multiplication. I'm multiplying x by 10, so I'm going to divide by 10. That cancels those out, and now I can go to my opposite side. I do the exact same math, so what I'm seeing is that if I have 180 degrees, I can divide that by 10. Well, once again, my top number goes inside my division box. My bottom number, my denominator, becomes my divisor. It's on the outside of the box, and I simply divide. 10 won't go into 1, but will go into 18 one time, and that is 10 with a remainder of 8. Then I bring down my 0, and 10 goes into 80 8 times. So what we have found is that every x is equal to 18 degrees. Well, what are the measurements for the other ones then? So now I'm going to take that 18 degrees and I'm going to plug it in for each of the x's in my equation that I set up, right? I know that 1, that understood variable 1, times the x, which we now said is 18, that tells me that the measurement for angle A is 18 degrees. When I go to the B, the one I've color coded in red, I had 4x, which would be 4 times x. So I have 4 times 18. And 4 times 18 gives me 72. So I'm saying that the angle B is equal to 72 degrees. And then I do the exact same thing for C. I'm going to plug in where I have 5 times x, I'm going to plug in 18 for x. So I'm multiplying 18 and 5, and I get 90 degrees. So C is equal to 90 degrees. So we found the measurement for all three angles of our triangle just by being told the ratio that they are in comparison to one another. But I want to check that real quick. And once again, a quick check for these is I want to add them all together. and see if I get to 180 degrees. And 18 plus 72 gives me 90, and once again, 90 plus 90, that's 180 degrees. So I know my answers are correct. So that takes us into a new topic, right? Triangles in the 180 degrees, it should have been taught in 5th grade. I don't know if it was or not. It really doesn't matter because I want to make sure that you know it. But this takes us into some terms that we may not know. Now, once again, we're given some kind of hieroglyphic things, right? With the M, weird, flattened L, and a 1. Well, there's going to be two ways that I can solve these, and one's going to take more steps. And that's the one I'm going to show you because we know all of that math. But I'm going to show you a shortcut, which is going to be new math to you. But I think it'll be a lot easier if you learn it. And depending on how we do today, I might do a second lesson on that. But we're going to look at the idea of angles and exterior angles. So once again, this is shorthand, right? So all this is telling me is that I have an angle, right? And the M is telling me a measurement. So this is said as the measurement of angle 1. That flattened L, they're just showing you the shape of an angle, right? Two rays that come together at a vertex at a point. So this is just really a variable, right? It's just a symbol indicating. So when we went back to variables, we said the definition of a variable is any letter or symbol that will take the place of a number. So as I'm solving for the measurement of angle 1, I just refer to that and think of that as a variable. There's no math to be done there. As I look at this particular triangle, I see that extension, and now I have not only letters for my angles, but I also have this other outside angle known as angle 1. Well, once again, if I look at the angles of a triangle, I add them together, it has to be equal to 180 degrees. But one of the things that we also look at is, well, if I know that this is 90 and I know that the B is 60, then we're going to say that the C is 30. But what is the measurement for angle 1? Right? So if I know that those all add together, can I find out what the measurement for angle 1 is? That answer is yes. Because if we think back to the very first slide that we did on this particular lesson, I reminded you that a straight line or a straight angle is equal to 180 degrees. If you didn't write that down on your first page of notes, then please write that down now, because that's an important thing that you need to know, understand, and own and take from this point forward, because you'll use this all the way through your high school math. The straight line is equal to 180 degrees. So if I know that my angle C is equal to 30, and I know that angle C plus angle 1 has to equal 180 degrees, then I simply do the math and I say, well, I know that angle C is 30, and I'm going to do my opposite function on the opposite side. So I'm going to subtract by 30 to get my variable, my label of measurement of angle 1 by itself. I cancel out my subtraction of 30 and I subtract on the opposite side. Well, 180 minus 30 is 150. So what we're finding is that the measurement for angle 1 is 150 degrees. So now I'm going to show you a second way to find out what that exterior angle is for measurement of angle 1. Now we've already found it. I'm going to keep it on this slide just so you can see that that's how we're going to get to it. But I need you to start by taking a note, and this is the biggest note of this entire lesson. I know it's a lot of words, and at first it's not going to make a lot of sense, and that's okay, because I'll show it to you what it means. And hopefully once you see it and we do it on a couple of them, then it will make sense on what you're writing. Depending on how well we understand this, we might do another lesson, and it's likely that we will, because this, for the first time, is new math. So I want to make this note, and we're going to call these the remote interior angles, an RIA. And what I mean by remote is it's not connected to. What I mean by interior angles, it means that they are the angles inside of a triangle or inside of a shape. The note is that remote interior angles, that the two angles of a triangle that are not a part of the straight line. So looking back at the image, I see the red, the dark red makes the straight line where we're trying to find the measurement for angle 1, right? So A and B in this example are not a part of that straight line. The only two things that make that straight line are angle 1, which we're trying to find, and angle C, which we know is equal to 30. So if I am using my interior remote angles, the two that are inside that are not connected to that straight line, then I can add those two together and get my exterior remote angle. So the one that's not connected to them and on the outside. So what we're saying is that if I add the measurement of angle A and I add the measurement of angle B, then I can get the measurement of angle 1, which is a remote exterior angle. Well, if I know that the measurement for angle A is 90 and the measurement for angle B is 60, what do I get? I get 150. And that's what we said we would get if I didn't have C, I solved for C, and then I took 180 and subtracted C, I still got 150. So let's look at what I'm talking about. So in this note, then you can see that we have a triangle and we have three extended lines. Those are going to give me my exterior angles. They've labeled it for us as interior, so we're talking about angles 1, 2, and 3. And then the exterior, we have angle 4, angle 5, and angle 6. So when I look at those, then I'm going to color code those for us. So hopefully it'll make it a little bit easier, right? So I have 3 interior angles, therefore I have 3 exterior angles. When we talk about remote, we're talking about not connected to. So we're going to start with how would we find the measurement for angle 4? So locate the measurement of angle 4. It is directly connected to 1. If I knew the measurement of angle 1, then I would just have to subtract it from 180 to get the measurement of angle 4 because they make a straight line. But let's say I don't. I only know the measurement of angle 2 and angle 3. I can still find it. So what we're saying is that the measurement for angle 4, I look at its remote interior angles, not connected to, and they're interior, so they're on the inside. So the measurement of angle 4 is going to be equal to adding the measurement of angle 2 and the measurement of angle 3, right? Because they are not connected to measurement of angle 4, they are remote interior angles. Well, if I look at the measurement of angle 5 down there at the bottom, we're going to do the same thing. I can see that if I knew the measurement of angle 3, it's connected to the measurement of angle 5. That makes a straight line that's 180 degrees. But if I don't know the measurement of angle 3, but I know the measurements of 1 and 2, then all I would have to do, since they are remote, not connected to the angle 5, interior, inside the triangle, angles, if I add those together, the measurement of angle 2 and the measurement of angle 1, then I can get the measurement of angle 5. And then when we look at 6, write down what you think the two remote interior angles are that you would add together. So hopefully you have, looking at 6, knowing that 2 makes a straight line with it, therefore they're remote, not connected to it, interior angles, that you wrote down that you would add the measurement of angle 3 and the measurement of angle 1. Now you could have flip-flopped them and put the measurement of angle 1 plus the measurement of angle 3, right? But we're looking at remote interior angles to find the one exterior angle. So understanding this new math, right? Understanding this new process, hopefully we can do the shortcut instead of having to do all the extra math that's involved. But I can take my two remote interior angles and add them together to get my exterior angle. I can build an equation from the information that I know. Now, they tell us in the bold black there, it says, suppose the measurement of angle 4 is equal to 135 degrees. Find the measure of angle 2. Then they say, well, angle 4, keep in mind, is an exterior angle. Its two remote interior angles, RIAs, are angle 2 and angle LKM. Well, what in the world is angle LKM? right? So they're just showing you that there is another way that we can show labels for angles. And these angles can be in any shape. They can give it to you in 3 letters if it's a hexagon, a decagon, a dodecagon, or a triangle in this case. An angle can be indicated with 3 specific vertices in a shape. What you're going to see is the 2 lines that make it up, and in the center, you're going to see the vertex of the angle they're talking about. So notice I've put in green the L, the K, the M in the order that they're listed, and the K is the vertex. So we could have also called this angle K. They're just showing you another way that you can see angles written down. Now, we know we're talking about angle 4, right? That's an exterior angle. It's remote interior angles, its RIAs, are not connected to 4. So 1 and 4 go together at point M. So we're looking at having the measurement of angle 2 added to the measurement of angle LKM, as they're showing you in this one, or we could say angle K. If I know that that is my equation with all sorts of variables, I want to plug in what I know, right? That's all I have to do when it comes to these types of situations. Plug in what you know once you have your equation written down. So I know that angle 4 is 135. So I have 135 is equal to, and the measurement of angle 2 is what I'm trying to find. And I know because there's that little box there in angle K or angle LKM, that's equal to 90 degrees. So now I have 135 degrees is equal to the measurement of angle 2 plus 90 degrees. Once again, we're back to algebra. I'm going to do my opposite function on the opposite side. Just notice that on this equation, I've set up the variable on the right-hand side with the answer on the left-hand side. It doesn't matter. I go to the side of the variable. That's why I've always taught it as find the variable and look at the math that's being done to it. So my variable is the measurement of angle 2. The math that's being done to it is I'm adding 90. So to get rid of it, I'm going to subtract 90. I cancel those out. Now I go to the opposite side of the equal sign and do the same math. So where the 135 is, I'm going to subtract 90, and I get 45 degrees. So what we have found is that the measurement of angle 2 is equal to 45 degrees. All right, so that's a lot of new math, but I want you to do all 9 questions. It's only the front side of a particular paper in your math book. So as you're working through it, I'm sure you're going to have questions, so please ask. And if we're struggling, I'm going to go ahead and do a second lesson on this. So hopefully the more we practice it, the better we'll get.